Hello, everybody. I'm Sarit. I'm a researcher at the University of Kaiserslautern in Germany. And my paper is regarding a tool for evaluating visual comfort from daylight through an immersive environment. This tool was developed as a part of the LISA project. The LISA project was funded by the German Federal Ministry for Economic Affairs and Energy. And this project is a joint collaboration between the German Research Center for Artificial Intelligence and the University of Kaiserslautern. So the primary motivation for us to work on the development of this tool was to provide architects, consultants, and designers with a VR-based realistic environment where they could visualize the results from daylighting simulations in a manner which was more immersive than what is possible from standard daylighting simulations. So the results from a standard simulation is shown on the upper right-hand side of your screen. In contrast, with VR headsets, the user is able to move around in a space and experience the daylighting scenarios in a more realistic manner. So there are several VR-based tools which are already present in both commercial as well as open source versions. So the key difference between the tools that exist and the one that we tried developing is that we wanted to merge the functionality of gaming engines with physically based simulations. So as you see from the points on the screen, we are still relying on physically based analysis, which means that the simulations that this tool is performing has its basis in weather data as well as realistic material information that might be present for a building model. Now, one of the key differentials between other physically based rendering engines and our tool is that we are able to evaluate multiple scenarios, rather multiple daylighting scenarios in a single session. Uh, and finally, we are merging the functionality of a gaming engine with building simulations, thereby providing the user with the best of both worlds. So they are able to navigate a space, they are able to experience a space with the functionality offered by a gaming engine, while at the same time be able to experience the results that would be generated from a physically based simulation. So since time is limited for this presentation, I cannot delve too deep in terms of how this tool was developed, but provided here is a general methodology. So essentially we start with a CAD model, which is then converted into a gaming engine model and a radiance model. The radiance model is the model pertaining to the radiance ray tracing system, which is the industry standard for visual analysis of daylight spaces. So beyond this, we end up with a gaming engine interface, which is where the user is able to navigate the space. And we also generate EQ rectangular images, HDR images, which are high dynamic range images, to provide the user with a physically as well as visually realistic perspective of what the daylighting scenario in that space would be. And finally, all this is merged together into a single interface, which is what the user is experiencing, as you can see on the right-hand side. So it is possible to use this tool with a VR headset as well as a desktop display. Now, the process of image generation is critical to our tool because we are relying on singular images for a given space rather than generating a whole bunch of multiple images. So what we are employing is a mapping system called as equirectangular mapping, which is where we generate a single image for a particular view and then map it onto a sphere type probe and let the user teleport into this space. Now, there are two different types of analysis that we are enabling the users to do. One of them is through a realistic looking tone mapped image, and the other is a false color image, which looks odd, but it kind of provides the user with the magnitude of the brightness or luminance that would be present in a space. Now, there are two types of analysis that are most common to our tool. The first one is a temporal based analysis, which means that keeping everything else the same, if we were to change the time or the daylighting condition, the results in a space. So what you see here is the same space with the same shade setting under different daylighting conditions. So this is 3 days and 3 different times. Now, the other analysis is a point in time analysis, which is where the shade setting is changed, but everything else in the analysis is kept the same. So in this way, the user can switch between a series of different shade settings as well as different daylighting scenarios. And this for us is one of the key differentials between our tool and what currently exists in terms of open source and commercial tools in the market. So finally, I'll show you a very quick demonstration of our tool, and I'll walk you through this video. So the basic navigation is essentially just walking around in a space. The one novelty of our tool being that there are collisions. So if the user intersects or comes across a physical boundary or a physical obstruction, then there'll be a collision. So this provides a more realistic perception. Then we are also relying on bitmaps and procedural textures to give a more realistic view of the space that is being visualized. And right now you see the teleporting function, which is where the user teleports from a gaming engine interface into an HDR view. So what we see now is the results which were generated through a radiance based simulation. So these images are in false color, so you can see that there is a scale which is on the right hand side, and what we see now is the evaluation of different blind settings for a single point in time. So as you can see, the patterns which are there in the room, they're changing because the blind settings are being changed by the user through keystrokes. Now, this is another situation where the blind setting is kept the same, but in this scenario, the daylighting conditions are changed. So you can see again that based on everything else remaining the same, when the daylighting scenario is changed, the brightness patterns in the room change. And so this again is akin to what I had shown before in terms of the two examples. So this was a quick presentation and demonstration of the tool that we developed. And I thank you for your time. And in case you have any questions, please feel free to contact me on the email address which is mentioned on the screen.